Hello everyone, today I want to talk about thread safety. When you go through the YouTube videos on thread safety, there are some people who make talks, but they sometimes don't have the same background with audio, so they can just use logs, just as seen in this little thumbnail here. Other times the videos are rather good, like with the channel, who really gives good examples and does not make things too complicated. But then there are also tons of videos that are just made by random Indians who also use very abstract concepts to explain thread safety. And if you're a little bit more like me, then I mean, of course, all of these videos are really good. Or like this one, it's really interesting, like all the computer file videos, but they are not meant to explain how to use threading or make things thread safe. They are more like entertaining videos for showing what you can do if you push things really to the limit and stuff. And there are some videos explaining some of the issues around threading, but it's actually not what you want, because you don't want to waste your time with the issues that could occur, because you will run into them anyway at some point, but you would rather want to have the solution, right? So I felt that all these videos together are sort of sometimes a little bit distracting from what you actually want to reach. And that's why I decided to make my own video. So I have an example for you. I'm working on this modular system, and I will make a video on the modular system in general at some point. But at this point I will just talk about the thread safety, because it will be a long enough topic. So yeah, this thing has a bunch of parameters, and you know that parameters in Juice are exposed as atomic float pointers. And it also has modulators that can be selected, and if you have selected one, then you can assign it, and then this has a new destination, this parameter, and you can change the so-called attenuversion of this assignment, and then you can also assign another destination to it, so you have multiple destinations on the same parameter and stuff like that. And of course, when you reopen it, then it has to be serialized. So all that is part of this thing, and I will talk about why that works. Okay, thread safety. So first of all, most of you probably already know that you can just take an atomic float something, and then if you want to store something in that in a thread safe way, you can say store value, with value being, you know, I don't know, some value. And then when something else tries to access something, then this store thing will wait until the other things are done. And it's also the same if you want to say something load. Then you are loading whatever is in something and put it into value. And this only happens after everything else that tries to access something at the moment has finished. But there is also a problem about all of this stuff. In one of my last videos about the spline editor, I tried to make something thread safe by use a state, and there was something like this: the state can be ready, it can be loading, it can be done, or something like that. And then I had an atomic state, and the problem was that I assumed that if we say if state load is state done, let's say when the state is done, then we want stuff to happen. And when all this has finished happening, then we set the state to ready. Now the problem is, if the state is ready, then we can load new things. So let's say that this happens from the audio side, and at the same time the GUI side says if state load is state ready, or something like that. Or maybe even state ready or state load. So it's just not done yet, or something like that, you know, any issue. Then something happens and state is state loading now. But this could happen, and it would set the state to loading while it was already on done and is now set to ready. Of course, you could just go ahead here and just say if state load is still state done, and only then state set to ready. But even in the little time frame between these 2 lines, this could happen. So whenever you have an if statement with your atomic state, it just makes no sense anymore and it's bad. So what else can you do? Let's say you have an arbitrary object of things, and it can have a lot of stuff, like in my case a vector of modulation destinations, and in my case that's even a shared pointer of these. So it can get rather complicated, and of course you would expect some functions in there like add modulation blah blah blah, some functionality, and remove modulation, and you can think that this would add or remove something from this vector, but at the same time you can process block this thing from the audio thread. So this is being called from the graphics thread and this from the audio thread, and the audio thread goes through all the modulations and calculates that and adds it to the parameter values and stuff like that. So obviously there's a conflict, but because if you go through one of these modulations and remove it at the same time, then that sucks, right? So what you will do is you will make a shared pointer of this object, and you also have a so-called release pool accompanied with that, and I will show you now why and how and why that works. First of all, I will show you the release pool. The release pool is a really easy concept actually. It is just an object that has a timer, so it runs on the message thread, and you can add stuff to it. And what this does is, if the object that you give it is not a null pointer, then we pull the scope lock and we place something into the pool, and the pool is a vector of shared pointers. So this could be any object type. And the timer callback works just like that, has a ScopedLock mutex, and then if some of the objects in this vector has a so-called use count below or equal 1, so below 2, because this is an integer, then it's going to be erased. Now what is a critical section and what is a scope lock? First of all, this is almost the same as if you would say std mutex, and this thing is almost the same as if you say lockguard. Well, when the scope lock is used together with the mutex, then no other thread can access the things that are going on in this method until the scope of this method has ended. So since the release pool is being used from the message thread, because it has timer and everything, and we can only add stuff from the message thread, that's why we can just use a lock there. And it is not directly used in process block, because process block only uses the matrix object that is in the, let's say, main shared pointer, and there's also only the second shared pointer in the release pool, and that's why it works like that. So what is the thing about this use count? Well, a shared pointer, it is reference counting how many pointers look at the object that is underlying in it. You also know unique pointer, which always just points to one object, which makes it unique, and shared pointer just can just share the pointer, and that way you can give multiple places ownership about a thing. And only when none of these pointers point to the object anymore, the object is deleted, or when it's part of the release pool, then it's also thrown out of the release pool when it's just below 1. And that makes sure that there always have to be 2 pointers looking at the object. And we make that by, first of all, making the normal object in a shared pointer. I called it matrix because it's for a mod matrix. And then when we have instantiated everything in our constructor, then we can add the matrix to the release pool, and then we can just start doing the thing. So yeah, I put a debug into the release pool, which helps us to read out the size of the pool and also the use count at every timer callback thing. So what we see now is what we would expect. The size is 1 and the count is 2 all the time. So there are 2 pointers looking at this object that's inside of this vector, and it's just one object in the vector at the moment. And we can move things around and remove things and add things, and it will just look like it was always the same. But if we actually ctrlf in this and then type in 3, then we will see that sometimes the count goes up to 3, even though the size is still 1. So that means there has to be some sort of thing happening sometimes, and it keeps coming back in regular intervals, where the count is 3 for a short time. And this happens in the process block method, because there we atomically load the matrix, which means that we make a new shared pointer to the same object, but we make this atomically so that nothing can change the object while we are loading it. And then we have loaded it and we can process block that. While this is the case, it has just one pointer more that looks at the same object. So if we went ahead here and said release pool debug, and of course also we go into the release pool and deactivate the debug in the timer callback, so we only see the one in process block, then we see that we will only get the ones with the 3 pointers. So what's the advantage of this weird thing? It is just that while we are using this pointer that looks at the object, we could make the old pointer look at a new object. And when the next time process block is being called, then it is the new object that is being put into new matrix and then being used, while this could be overridden. And because we make this atomically, it's thread safe. And you know, this does not require an if statement, so it's good. Now I want to show you an example for where that actually matters. For example, let's say in SetState information we want to serialize the information. It comes from the binary and it's being put into the value tree, and of course when it's in the value tree we also want to have the information in our matrix. So we atomically load the matrix, and I made this little copy function in my matrix object, which just basically creates a new shared pointer to a matrix, but with a new object inside of it. So this is a new object, and because this is an independent object from this, we can just, without being thread safe, set the state here and add a bunch of stuff without caring about it. Then we add this to the release pool. So the release pool has 2 objects now, and they each point to a different thing. And only then we atomically store the pointer that points to this new object into the old shared pointer thingy, so that it also points to the new object and not to the old object anymore. And in order to test this, we will now go ahead and say release pool debug, and then we will say release pool debug again after the atomic store. So we can see we have basically added something to the matrix, which makes 2 objects be in there, and each of them has points to has 2 pointers that look at the 2 objects. But then we replace one of the pointers with the other, and then suddenly we get this imbalance where one of the things is 1, which means on the next timer callback it's being deleted. This is the old matrix, and the other one is on 3, which means when the scope ends it's on 2, and then it will just be the same as the old one doing its thing and so on. So this is how it works. So this is basically all you have to know so far, but I just want to show you another example just in case that it was not clear enough yet. First of all, this is an example where you don't need to use this whole thing with the release pool and the shared pointer, even though you still get this matrix with atomic load, so you can do stuff with it. We are in the selected modulator gain dragger. Some modulator is selected, and because this parameter has actually a destination of that modulator, this thing is shown, and this thing, this little m here, is the selected modulator gain dragger, because you can drag the gain with that. Actually, I should recall that to Attenuvertor or something. So when you drag it, obviously it does this. So since this is not adding or removing something, but just basically storing a new value in a std atomic float, we don't have to copy any stuff or replace any stuff. So we can just get the matrix, make all of our calculations, and then set the Attenuvertor with this fancy looking line that is just needed because we're working with a lot of pointers here and IDs and stuff like that. It's looking horrible, but it's actually easy. Now let's actually go to the ModulatorDragger. The ModulatorDragger is this thing that you can drag around to select a new parameter as a destination for this modulation. So yeah, you can drag it around, and if you are hovering over a parameter that can be modulated, so not one of these, but these actually, then you can drop it, and if you drop it, mouse up is being called. And if the hovered parameter is not null pointer, which means that there is something below it, like this modules mix parameter, then a bunch of stuff happens. And we want, obviously what we want is that we want to add a new modulation destination to the modules mix there, right? So we have to atomically load the matrix and copy it just like we did in SetState. And then we can apply all the stuff to the new matrix. And then it's just the same. We can add the destination, the modulation destination to it. We can put it into the release pool, and we can atomically store it into the old shared pointer matrix. And then the other stuff that happens in this component, you know. So yeah, as I said again, I'm not trying to diss the other YouTubers who talk about thread safety. I just think that some of them are, first of all, not so much into audio processing, and secondly, sometimes a little bit too advanced. So this is not a very beginner-friendly topic in general, but I try to give it a little bit more of a practical context here, you know. And secondly, I would like to thank my friend Peter, who showed me this method. He is a very smart guy. He studied maths, he's a math professor or something, and also worked in the industry as a C++ developer for more than 20 years. So he's much more experienced than me, and he showed me just this, and I was blown away by it, and it was basically all I spent my time on the last week, because this is just so powerful, and it's actually not even that complicated once it is done in some way. Then you can just reuse it on everything, because you can put anything into the release pool. Pretty sure that I will have to rewrite my spline editor again in this way to make it really safe. So I think I learned something really valuable this week, which I'm very thankful about. And I hope that you like this video. If you like this video, then you're cool. And if you don't like this video, then you could tell me why, and maybe I can do something about it. See you.